Hello, good afternoon, all my friends and all lecturer. Thank you for your time. Today we will presentate about momentum and impulse. My name is James, and in here we have Alvina Olivia, Annasya Koesty, Chairunnisa Yasmin, and Sandrina Aurelia. The first thing I will explain is about momentum. Linear momentum, or simply momentum, is the product of the mass and velocity of an object. Like velocity, linear momentum is a vector quantity possessing direction as well as magnitude. And the method of this momentum is momentum equals to mass times velocity. Using P as a symbol for momentum, the SI unit for momentum is kilogram meter per second. And the next thing of the momentum is all objects have mass. So if an object is moving, then it has momentum. It has its mass in motion, and the amount of momentum which an object has is dependent upon two variables. The first one is how much matter is moving and how fast the matter is moving. Momentum is mass in motion. The examples for the momentum is like a bus can have a large momentum even if it is moving very slowly because it has a large mass. Because the method is mass times velocity equals to momentum. The second one is about a bullet can have a large momentum even if it has a small mass because it is moving at high velocity. Because the velocity higher than the mass equals to momentum.
If an object is at rest, it has no momentum, no matter how large its mass. Momentum is not the same as inertia, so momentum equals mass times 0 equals 0. Inertia is another property of mass that resists change in velocity. However, inertia depends only on mass. Inertia is a scalar quantity. And momentum is a property of moving mass that resists change in a moving object's velocity. A momentum is a vector quantity. So here is some questions about momentum. So determine the momentum of a 60 kilogram halfback moving eastwards at velocity 9 meter per second. So we can use the formula that we say before is momentum equals mass times velocity. So 60 kilograms times 9 meter per second equal 540 kilograms meter per second to east. And the same formula we can use to answer the question B and C.
Next, we are going to explain about the change in momentum. Newton's second law states the net external force acting on an object is equal to the time rate of the object's momentum. So F net equals delta P per delta T. Next. Force is rate of change of momentum. Momentum changes when a net force is applied. The inverse is also true. If momentum changes, forces are created. If momentum changes quickly, large forces are involved. These concepts are merely an outgrowth of momentum's second law as discussed in an earlier unit. Newton's second law, F net equals mass times acceleration, state the acceleration of an object is directly proportional to the net force acting upon the object and inversely proportional to the mass of the object. When combined with the definition of acceleration is A equals change in velocity per time, the following equalities result. F equals mass times acceleration, so it's mass times delta velocity per times. If both sides of the above equation are multiplied by the quantity of t and a, new equation results force times time equals mass times delta velocity. In physics, the quantity force times time is known as impulse, and since the quantity mass times velocity is momentum, the quantity mass times delta velocity must be change in momentum. The equation really says that the impulse equals change in momentum.
The impulse momentum theorem. The impulse due to all forces acting on an object, the net force is equal to the change in momentum of the object. F net T equals delta P. We know the units on both sides of the equation are the same. But let's prove the theorem formally. F net T equals m times acceleration times t equals m times delta v per t times t equals m delta v equals delta p. The product of a force and the time the force acts is called the impulse. Impulse is a way to measure a change in momentum, because it is not always possible to calculate force and times individually since collisions happen so fast. Impulse is a change in momentum in a short time requires a large force. A change in momentum in long times requires a small force. The first picture says about T changes in momentum. The second picture shows us about the F change in momentum.
Next, for the force and momentum change, to find the impulse, you rearrange the momentum form of the second law. It can be found by the formula of F times delta of time equals delta of P. Impulse can be expressed in kilogram meter per second or in Newton per second. Impulse is defined as the product force acting on an object and the time during which the force acts. The symbol for impulse is I. So, by definition, I equals F times T. For example, a 50 Newton force is applied to a 100 kilogram boulder for 3 seconds. The impulse of this force is 50 times 3 equals 150 Newton second. Note that we didn't need to know the mass of the object in the above example. For the impulse units, I equals F times T shows why the SI unit for impulse is the Newton second. There is no special name for this unit, but it is equivalent to a kilogram meter per second. F net equals M times A shows this is equivalent to a Newton. Therefore, impulse is equal to a momentum but different in units, which leads to a useful theorem. That's all for our presentation about momentum and impulse. We hope that it can help everyone to learn more about momentum and impulse. Thank you for watching.